You are so pretty.
Classic.
Oh,
She's too pretty.
You are so pretty. And you guys are too. All of you.
we're all pretty.
Well,
Pretty
thanks,
nice.
Tyler.
Welcome to Non-Sequitur. I'm Kyle Curtis, joined always by Steve McRae and David. Hello, David. David's not wanting to talk. But anyway, he was very sassy last night. Did you notice that?
Yeah, he had a lot to say. It was actually pretty interesting because I didn't know David knew that much about gyroscopes. I was impressed
Sassy
myself.
If you didn't know, by the way, Steve was partaking in allegedly Dave's advice last night. So if his skin has a unique tinge of yellow to it, you know why. We are joined to
No, it wasn't.
We are joined by two very special guests. Both have been on the show before, quite a few times actually. Dr.Sy Garte. Hello, sir.
Hello, how are you?
And Dr. R.M. Huffman. And who is this lovely
This is
lady?
Lala. This is Lala.
There.
She is 4.
Can you wave? I see your pictures all the time on Twitter.
Yeah, she's very fancy. She's got fancy curly hair, but now she's shy.
Well, she's adorable. So before, I'm just going to go through a couple things that we have coming up, and then I'll throw it to Steve to introduce the topic tonight. Tomorrow, you can join us at 8 o'clock. We will be joined by Dr. Stephen DiMattei again. He has been on before. Sunday, we have Rags and Bionic Dance. We'll be taking on Matthew Powell. And Monday, we have an escaping Scientology special. A guy who got out of Scientology will be coming to. It was in it very deep. He's got a really good story. So join us on Monday. That's going to be at 9 o'clock on Monday for Deconverted Scientology. Tuesday, we'll be doing something very different, very radically different. But we've had several people request that we do this. We went back and forth on it, but ultimately decided that why not give it a shot, since it's something that all of us use every single day, and it's in our life everywhere, on the computer, in your phone, everything. So we will be doing a Google versus Apple debate on Tuesday. We have two very strong proponents of one or the other. We'll see how it goes. It should be interesting. And then Wednesday, probably one of the most exciting streams that I think that we're going to, for me anyway. Everybody knows how much I love space and the universe stuff. One of the engineers for NASA that actually is responsible for some of the software that took the Cassini space probe that flew past Saturn and then deployed the Huygens probe into Titan's moon will be coming on to talk about that, how that was, went on. He's also got several patents for things that he's invented. Very fascinating guy, but he will be with us on Wednesday. And then Thursday, if you saw last night's stream and didn't think we could top that, well, we can and we will. We have a gentleman by the, I'm not sure if his name actually, but his handle is The Mind Experience. You can look it up. He will be joined us with KC. She will be with us, and the Mind Experience does healings through Skype. So we will dive into that world on a Thursday. So a big week coming up. You can catch more about what we have coming up at nonsexshow.com/schedule and see the times and the guests there. Okay, Steve, what we got going on tonight?
Well, tonight we have the battle of all battles when it comes to what we talk about a lot, creationism versus evolution. I think tonight we're going to try to approach it from who has a more accurate model, who has a better model that actually can use for explanatory purposes and predictions. So we have two actually educated people. We have an MD, Dr. R.M. Huffman, a medical doctor, and a anesthesiologist, young Earth creationist, and of course Garte, which is a PhD in biochemistry. I saw I would place you under theistic evolution, correct? Is that kind of a fair thing? Okay.
Yeah.
All right. So theistic evolution versus young creationism. And I think that because we talk about these things an awful lot, and literally Kyle and I could probably spend hours doing it, we're just going to shut up and let you guys have a discussion on it. And if you guys do get into an impasse, like we've had in other past debates or discussions, then we'll kind of like just jump in and kind of move along. But for the most part, I just want to hear you two kind of go at it. I think that's kind of the approach we're going to take on it today.
Yeah.
Sound good?
So
good.
it'll be like Steve, you and me don't exist.
I still exist, but
I don't believe you do.
Yeah, I'm just going to believe that I don't exist for this purpose.
By the way, guys
Where
out
you-
there for listening, before we jump in here real quick, if you're listening, we had colors, we had triangles, we had Steve. Well, before the show, you can throw numbers on that list as well. Numbers don't exist either, just in case you're keeping a tally. Anyway, go ahead.
I'm so confused right now.
You don't want to know.
I feel I'm having the angst about existential crisis. Okay. All right. So, anyways, we're just going to jump on into who said that. Who said that? Where did that come from?
What's going on?
So, how about you guys just like take 2 minutes, kind of introduce yourselves, your positions, and then we'll go right into the topic. So, Sy, you want to go first? Kind of tell us about yourself and your position, and go ahead.
Yeah. I'm a biochemist. I began life as an atheist. I grew up in a very militant atheist, very left-wing family. My parents not only didn't believe in God, they thought God definitely did not exist and the idea of religion was actually evil. So that was my background. I'm not going to go through the whole story, but eventually I came to doubt that worldview. And once I doubted it, I became open to the possibility that there was something beyond materialism. I became a scientist, and the more I learned about science, the more I felt that materialism wasn't explaining everything there was, especially within science. And then through the grace of God, I experienced the Holy Spirit directly, and I became a Christian. And I'm now very active in my church. I'm actually the lay leader of my United Methodist Church. I go to church every Sunday. I consider myself a very devout Christian and to some extent an evangelical, because I am trying to spread the word wherever I can. However, I never gave up any part of my scientific worldview. And when I first realized that I was a Christian, and before I started going to church or met anyone else, I was kind of upset because I felt that I was in trouble now. I was going to have this cognitive dissonance. How could I believe in Christ and science, especially, things like evolution? And I thought I was the only one who faced that problem. And then I read this book by Francis Collins called The Language of God, which has been extremely influential for a lot of people who have this same issue. They think, well, I can't give up science. I don't want to give up Jesus. How do I do that? And I discovered that, in fact, the idea that there's a conflict between science and Christianity is a myth. It really was a myth started in the 19th century. Most scientists in world history have been Christians or Muslims or Jews. Religion and science had never conflicted until the end of the 19th century. And although I love Darwin and his theory, the Darwin Revolution had a little bit to do with that, maybe a lot to do with it, I will concede. But at the end of the 19th century, a couple of books were written about the warfare between science and religion, and that took off. And now we have a situation where the majority of scientists are either atheists or agnostics. I'm not sure it's a complete majority. It's a very thin majority, if it is. But anyway, so my position, you called it theistic evolution. The other word, which I prefer, is evolutionary creationism, because I do believe in creation. I believe that God created the universe, the world, us, everything. And I believe that evolution is the tool that God used to create life as we see it. And that there is no conflict with the basic tenets of Christianity. There may be conflict with parts of the Bible, and we will probably get into that in some detail as we go. But my mission, if I have one, is to be able to tell young people, especially students who may have come from a Christian home, go to college, learn biology, learn physics, and begin to doubt their faith because either their professors or somehow they're being taught that it's one or the other. You either have to be a Christian and, drop evolution, or you can believe in evolution and you can't hold your faith. And a lot of people are leaving the church. We know that. A lot of people in that generation are leaving their faith for various reasons, but one of them is the issue of science. And so my goal is to try to help those people see, as Francis Collins has done, and Biologos and many other people and many other organizations. I'm certainly not alone or even a leader in this, but my goal is to help those people see that there's no problem with holding on to modern science and your Christian faith. And I've said a lot, so I'll stop.
No problem. Dr. Huffman, you're also a Christian as well, and you come from a very different perspective on it. You obviously come from a younger creationist perspective. So can you kind of basically tell people how you came about having the same type of Christianity, belief that Christ is Christ and is the risen Lord, but from a younger creationist perspective?
Yeah, sure. So, Sy, I agree with almost everything that you said. I think everything you said is exactly right. Except obviously we have a severe disagreement on the scientific credibility of the macroevolutionary model. But beyond that, I'd echo everything that Sy said. Now, I grew up in a home that when I say I'm a young Earth creationist, what I mean is I approach Scripture from a historical grammatical hermeneutic, which just means that Genesis is history and we read it as history, as opposed to Psalms, which is poetry, and parables, which are metaphorical, which obviously leads me to very different conclusions. But everything that Sy said, there's no conflict between science and religion, and there isn't. The historical pedigree of Christian scientists, and that includes Kepler and Newton and Pascal and Pasteur and Faraday and Linnaeus. Francis Bacon, who is considered the father of empiricism altogether. If they founded a field or have a unit of measurement named after them, chances were they were Christian. Mendel, scientific history is replete with Bible-believing Christians. So if nothing else, over the next half hour, which is probably what I got, let's dispel this notion that somehow Christians who believe in Jesus Christ as a risen Lord can't do science. The fact is, empiricism doesn't care about your beliefs about origins, right, which is why you can be a Hindu and be a Muslim and be an atheist and be an evangelical young Earth creationist or an evangelical evolutionary creationist. We're talking about two different things here. When you're talking about empirical science, the kind that puts, shout out Kyler, men on the moon, doesn't matter what you believe about origins. You can get down there and you can experiment. You can do bench science. When you're talking about origins, though, ultimately you're talking about a philosophical, historical proposition. So I think we're going to see that's where every difference lies. And it's fun to talk about nuts and bolts and DNA and mutation and all the nitty gritty about the actual details of it. But what this is going to come down to is how do you interpret it to come to a conclusion about origins. What else was I going to say? I'm not sure because I'm sick and I'm all NyQuil'd up. So this should be fun. This should be fun, guys.
Sweet.
This is going to be awesome.
This should be good. Sweet. This should be good. But yeah, beyond that, I think. Oh, this is what I was going to say. It's important to remember when we're doing this stuff. Hugh Ross kind of splits the difference between us. You think that's fair to say?
Yeah.
Stephen Kyler?
Yeah. He tends more to old Earth creationism.
Yeah, no. He's older. Yeah. He's old Earth, but I don't know how strong is he on. I don't think he's a macroevolutionary guy.
He accepts evolution up to the point of ensoulment, and then Adam and Eve were actually ensouled by God. So that's where he kind of stops at that point, from what I understand from talking.
Well, there's a flavor there. I mean, obviously there are lots of different flavors, but important to stress too, especially for any Christians watching, this is not a salvific issue. I think it's an important issue because I think it speaks to the credibility of Scripture upon which the credibility of the gospel rests, and that is obviously salvific. But what you believe about Genesis isn't going to get you into heaven. So it's fun to talk about. I think it's useful and worthwhile to talk about from a theological and a scientific perspective. And there's so much to talk about.
Well, let's get into it.
Yeah. So do you want to take it from there and kind of like do a compare and contrast between the evolutionary model and a young Earth creationist model? And I know you use the word creationism for theistic creationism, but just is it okay for this argument? If we use creationism, it's just easier to refer to young Earth creationism, or do you want me to differentiate?
No, it doesn't matter.
Okay.
And in fact, it might even be foolish to try to, because the reality is that pretty much every person in this discussion, as Aram was saying, may have their own views. Exactly. For example, I also believe in ensoulment of human beings, and I believe evolution has stopped once human beings arrived on the scene, and we can see that today. I mean, if you look at how humans live now compared to how they lived at the origin of humans, say 50,000 years ago, if we believe in an old Earth, it's completely different. But none of that is because of evolution. It's because of cultural evolution. It's because of our brains, not because of our genes. There have only been a few mutations in human beings since that time. So what's happened is we have changed. The way we live has changed, but not because of biological genetic determinants. We've changed because we have something about us that's unlike any other species. We can change. If you look at any other animal, if you look at apes and say, are they living today any differently than they did 4 million years ago? The answer is no. We are living differently today than we lived 4 years ago. I mean, this keeps happening. And the reason is we're really an unusual species. And I think that, I mean, I don't really have to go into things like art and music and science and thought and love and all of those things also. But the point is that what I'm trying to say is that I do agree with the idea that perhaps you, Ross, said. I didn't hear him say that, but that when you reach human beings, it's no longer Darwinian type of evolution, as far as I can tell. So, and RM, I wanted to ask you, when you say origins, I'm not clear. Do you mean the origin of life, or you're talking about the origin of species? Because
everything.
Okay.
Everything.
So
everything.
I'd like.
No, go ahead.
No, it's all right. I just think that we have to be careful, because to me, as a scientist, as a biologist, I think of evolution as a biological process only. Evolution, as we know it, is a very biochemical, technical process that involves, the change in allele frequencies in genes and different proteins that are produced. That only happens in living organisms, in living cells. So the question of the origin of life, to me, is completely different. And
we're not talking about that.
We're not talking about the origin of life. Okay.
Yeah, no.
Because
we're not talking about abiogenesis.
Okay. Good.
But
because there we would agree completely, probably.
Yeah. But the point it remains true if you're talking about the origin of life, the origin of species, the origin of the time, space, matter, universe. Mm-hmm. All of that is outside the purview of empirical evaluation.
Right. I agree.
I mean, it all has to. Now, everyone picks and chooses from the same body of evidence, and then you have to interpret it. It's not self-explanatory. You have to pick your axiom. You have to pick your presupposition, and then you have to build a model. But yeah, and obviously for now we're sticking with biology.
Right. So, I mean, I'm glad we got that straight, because that's very important. I also agree that origin of the universe, origin of life, even origin of human beings is not part of this discussion. We probably agree completely on those origins.
No, I totally agree.
When we talk about evolution, however, and that the origin of the diversity of life, the various species that we see, I guess what I'll say about that, I don't know if we should get into the science, or we can just, keep it a little bit more theological for the moment. My view is that and we have to put the Bible aside for the moment, put Genesis aside, we'll get back to it. But for now, when I look at the mechanism of evolution, the way that it works to produce the incredible beauty that we see around us, to me, that's a testament to God's majesty, more than a creation of however many kinds that were theoretically created in Genesis. I find that evolutionary process is actually spiritually, theologically, in a Christian sense, very consonant with my beliefs about God and the universe.
The problem is it's not consonant with the actual text. When you and I are talking about this, we can't put the Bible aside, right? We both accept
That's right.
supposition. So that's actually a huge topic. And like I said, this is like 5 subjects. One thing that I think is vitally important is to make a distinction when you talk about evolution. In literature, in just layman's language, in science articles, and among professionals, there's a massive conflation between 2 different processes. You know I'm going with this, Steve. And the conflation is between adaptive speciation, which is termed macroevolution, right? And that is the observed capacity for animals to variate within a kind, right? Darwin saw that. Like, that's undisputable. Everyone agrees with that. And if you have any fixity of species creationists, I'll get on and tell them they're wrong. But animals can adapt. They can. But it's always within a kind, and that's the difference. So Darwin was pre-genetics. He was pre-DNA. So he sees... did we talk about fancy pigeons? Darwin loved fancy pigeons. That's where he got a lot of his ideas. And he saw these people, breeding sky rats into all these different variations. And then he saw the same thing in the wild. And he had bought Charles Lyell's books about geology, which kind of preached uniformitarianism, and all of a sudden he had all this time to work with. And he said, so let's take this little bit of adaptation that I see, and then we multiply it over, thousands and millions and millions and millions, and now 4 billion years. And we can explain, what's come to be known as classical Darwinism. We can explain the origin of species by means of natural selection, or the preservation of favored races in the struggle for life, which is the title of this whole book. So what we got to remember is that was pre-Mendel, who then founded genetics, and it was pre-Watson and Crick, who discovered that DNA was a double helix. And at that point, my contention is that macroevolution, this idea that everything can be considered to have everything can be traced back to a common ancestor. And I'll pause right there. And I think, Sy, would you agree that a materialistic macroevolutionary process is untenable from a scientific perspective?
No.
Okay. So God's in there somewhere, but you're not sure where?
Oh, I think God's in there in the origin of life, and I think
your contention is that the macroevolutionary process can be purely materialistic.
Yeah.
Okay.
It can be. I don't know if it is. It may be. There's a whole debate, about whether.
That's actually a great point, and I think that's worth stopping on for a sec, if y'all don't mind.
Okay.
When we're talking about this, we can talk all we want about, we'll get into mutations and I mean, Denton and Behe and Sephardi and Spetter and all the different, reasons that I think macroevolutionary processes it's just not scientifically tenable. But axioms are so important with this, because the fact is, if you told me here is a scientist who got in a lab and he started out with a single cell, and then he documented every single point by point mutation, every transitional form, and it's all there. You could go to the lab and see them. You can see every single transitional form that's responsible for every single kind of life on Earth, most of which are extinct. There's so many cool extinct animals. And here's every mutation. And here's how every mutation affects the epigenetics of the DNA. And he had them all right there. All that would tell you, and this goes back to this being a historical proposition, all that would tell you is that is a possible answer. I would still reject it as being the actual historical answer, because I consider Genesis to be an eyewitness account, which to me is dispositive and still explanatory. So yeah, let's remember that this is very much based on philosophy. But so Watson and Crick discovered DNA, right? which meant the only game in town. And jump in, Sy, at any point if you want to disagree or talk about something. It means the only game in town for genetic change was mutation. That mutation. So Darwin should have macroevolution should have died right there. But at that point, it was 100 years established as the paradigm. For mutation to be a credible engine for a macroevolutionary change, a mutation would need to do two things. It would have to add de novo information to the genome. And every single base pair of DNA for every single species that ever existed has to be accounted for by these, unless you appeal to a process that nobody knows anything about. Mutation's the only game in town. The mutation would have to add new information. Even if you're talking about things like transfer or transposition, you still have to account for the origin of that information. And then the other thing it had to do was be beneficial. If it doesn't provide a survival benefit, it doesn't do any good, right? So that's macroevolution. There are no mutations that meet those two criteria. There are beneficial mutations in some organisms. I mean, there are a couple of antibiotic-resistant bacteria mutations that are deleterious because that's what mutations are. There's a kind of beetle that doesn't have wings because the parent species came to an island and it was windblown. So all the beetles with wings died. They got swept out to sea. But the beetles with mutation that deleted the wings is deleterious. They survived. So there are beneficial mutations, but none of them are additive to the genome. So here's a book. So y'all ever read this, Steve or Sy or Kyler? Not by chance?
I've heard of it.
I've not read it, but I'm familiar.
I've not.
I mean, I've heard of it.
Good book, if for nothing else, to see a viewpoint that's unique. This guy's not a creationist. He kind of wants to do his own thing to promote his own views, but his picture is saying that microevolution, which again, it's kind of a misnomer, right? It's adaptive speciation, which is a process of genetic loss. When a parent population speciates, let's say a parent population of birds, of Darwin's finches, right? It has a genetic capacity for big beaks and small beaks, and then only the big seeds are there, and that species evolves, right, to only have big beaks. Well, that's a change, but it's not a change that's in an upward direction, right? The genetic information for the small beaks is gone. That's what you see. That's what you see with gray wolves, all the way down to, every breed of domestic dog was shoot, Steve.
Can we try to get real quick before we move on to something else? Give him a chance a little bit to respond, so we don't go over multiple different things at once.
Yeah. Sorry.
Yeah.
No problem. So conclusion. When you're talking about microevolution and macroevolution, you're talking about processes that go in two different directions. You're talking about one process that fits a creation model perfectly. For example, how did Noah fit all the animals onto the ark? Well, adaptive speciation is a thing. He doesn't need to take 2 panthers and 2 lions and 2 tigers and 2 jaguars. He can take one kind of panthera, one pair of those. It fits fine. What it doesn't do is lead to a macroevolutionary process, which everyone should have realized in the 1950s. And by then it became more of a religious proposition, for lack of a better term. My contention very strongly is when you're talking about evolution, you can't jump from evolution is observed and then evolution is responsible for common descent, because what you're talking about is 2 different processes and you're just giving them the same name. I think it's very, very important. You can use microevolution or macroevolution, which are not creationist terms, by the way. I mean, G.G. Simpson in the 40s used those terms. So kind of misnomers, but they're different processes.
All right, let's give Sy a chance to respond on that.
Yeah, go for it, Sy. Sorry.
That you said a mouthful.
Yeah.
Okay, so let's see. Let's tackle a few things. Actually, I like to look at things historically, as you did. When Darwin proposed his theory, it made a big splash. But interestingly enough, it kind of died out because there was very little evidence for evolution on a materialistic, as you'd say, a mechanistic way. Nobody knew how it could work.
Yeah, sure.
And when Mendel's work was rediscovered in 1900, it's amazing. Most people said, well, that has nothing to do with evolution. Evolution must be wrong because now we have all these genes, and how does that fit into evolution? However, in the 1920s and 30s, with people like Sewall Wright and J.B.S. Haldane and various other statistical biologists who were looking at the whole idea of genetic inheritance, it dawned on them that this could be the mechanism for evolution, that the variation which Darwin identified, which everybody knows exists in animals in any population, just look at the four of us. We all look different. We're all the same species. And that's true for all animals and all plants. So where does that variation come from? Darwin had no idea, and he said as much. He said, I have no idea where the variation comes from. Now we knew where it came from, that it came from different genes. So what happened then was, it was a moth bothering me.
I thought you were just excited.
No.
Okay.
What happened then was a revolution after Watson and Crick, as you said, in the 50s and 60s and 70s on understanding how genes actually work and how they relate to everything that we know in biology. And part of that revolutionary and very exciting period was the application of genetics to test Darwin's theory of evolution. And the tests were quite simple, and they were falsifiable. If it turned out that various species were related to each other, one would imagine that you would find clues to that in the genomes. And we found, I didn't do it, but plenty of people found amazing clues, all of which pointed, just as the fossil record does, and we get to that later because that's a separate issue, but all of the genetic information that we had about all species indicated that those species that seemed to be closely related to each other by just looking at them actually were genetically closely related. Now, I know the argument to that is, well, yeah, God, gave everybody that was similar specific genomes that gave that similarity. But then we find these things like pseudogenes and insertions of retrotransposons, which are accidents. And you wouldn't expect those to occur in two species independently, differently, unless they came from each other. And that's exactly what we find, almost without exception. Now, the other thing I really want to address right now is this issue of no new information. I don't actually know where that originally came from because the scientific record is quite the opposite. We know from looking at genomes again that there have been many instances of gene duplication. In fact, in several cases at the beginning of the vertebrates, we know that there was a whole genome duplication, so the entire genome was duplicated. And what gene duplication does is it allows for a large amount of mutation to occur in every gene because you have another copy that works. So the animal doesn't die if you mutate at random. So it's like having an extra, set of genes that you can play with. And that's what happened. And what we find there is that ended up adding a huge amount of information, vertebrae, lungs.
The problem is, you're begging the question. You're not concluding things from what you're saying. You're assuming that a process happened, and
Okay.
then you're interpreting them to say, and here's how the process happened. There's no confliction with a young Earth creationist model either, and you're not getting into specifics.
Well,
and I'll also say,
I can.
Dr. Huffman, one second.
Go ahead.
Let Dr. Garte finish
Yeah.
his thought, and then we'll jump right into that because he was very respectful when you were talking and didn't interrupt. So let's keep that.
What we do have, and it's true that we don't have experiments. There's no experiment that you can do to show evolution working. But what we do have are fossils, and we have animals that are alive, that are related to each other, and we have their genes. And in many cases, we see a change in the body plan, a change in what you would call macroevolutionary, changes within not just beak size, but a whole different way of looking, maybe wings without wings and tails without no tails. And we find the genetic mutations that cause those. And those mutations are not always, sometimes they are loss of function, many times, but not always. Often they're the formation of a new gene, and that new gene is found often to come from, a specific previous gene that mutated a lot, or even in some occasion, that we have orphan genes, which basically are stretches of DNA that haven't done anything, and now they're suddenly, they've mutated to the point where they have a function and they begin to put out proteins. And there are very specific examples. I mean, I could give you a list. I have them, but I don't know if we want to spend time on that. I mean,
not enough time for nuts and bolts.
It's not worth it. But these are well known. I mean, and we have the fossils. We have transitional fossils, and I'll just mention as one example, the best known is the whale, which has like 10 transitional fossils on the way from what looked like a hippopotamus, was the common ancestor of the hippopotamus and the whale. And one branch became hippopotamus, another branch became whales, and all the transitions between that original ancestor, a fossil that we have, and all the other fossils that we have, we can trace. We have them, they exist, and we can look at their genes, and we see the genetic mutations that caused all the changes that we saw in these fossils. Sorry, go ahead.
You can't look at the genes. You can look at hippo genes and whale genes. You cannot look at the genes of fossils. That is absolutely not true. We're talking about.
Okay.
When I'm talking about
looking, I mixed two things there. When we're looking at the fossils, we're looking at the changes in structure and shape. But what we can look at the genes, and this is what I mixed up. We can look at genes for living animals that are transitional between one thing and another. And so we can see, for example, what the genes are that, a fish versus an amphibian versus a reptile, just to put it very simply, a reptile and a mammal. And as we go along that process, we see the genetic changes that resulted in all the differences in the phenotypes of these animals.
And again, you're totally begging the question. You would never ask that question unless you first concluded that there was a relationship at all, that there was an evolutionary relationship. The fact is, have y'all, so here's the other one that's a non-creationist book. Y'all read Denton Theory?
Yeah, I know Denton I reviewed that book very well, by the way. So I gave it a positive review.
Yeah, it's a good book. And obviously you didn't come to all his conclusions, and he hasn't come to my conclusions at all. But one of the things he talks about is, as you know, the fact that there's no moving from amphibian to reptile to mammal. There's just mammals and reptiles and amphibians, and the fact that you can classify all of them so hard and fast, there's no question what amounts to it, is an indication that things were not gradual at the very least. And I'll say the fossil record as well. I mean, the fact is, a fossil record, which was always Darwin's kind of weak spot, he recognized that it was a weak spot, and he assumed that the fossil record would be added to in such a way that it would demonstrate that he was right, and that's not what's happened. When you talk about, it's not. It's absolutely not. When you talk about and that's why Gould came up with punctuated equilibrium, because the fossil record is a record of saltation.
Yeah,
it's not.
That's true.
It is not a record of gradualism. You do not have transitional forms.
Whoa. Back up.
If you say that you have transitional forms, you can point to maybe a handful of examples. But they're examples of what? Fully functioning animals with soft tissues where we can observe their biochemistry and physiology? No, they're partial bones.
Those are true for fossils. Let me back you up a bit, because
hold on, Dr. Huffman. Let him. Yeah,
go ahead.
Let's do one idea at a time so we don't go all over the place.
It's a huge field. That's true.
Yeah.
First of all, Darwin had very few fossils at hand. That's true. We have a huge number of fossils, transitional fossils as well. And the idea that there are no transitional fossils is simply not true. The number of fossils that we have is in the thousands that are transitional. We have living organisms that are transitional, like Tiktaalik, which is between a fish and a amphibian. We have other living fossils, quote unquote, living transitional forms. So it's not true anymore that there are no fossils. That has not been true for a long time. What was the other thing you were saying? I wanted to get to.
I don't know. It was a lot.
Saltation.
Saltation. Yes.
Saltation and punctuated equilibrium.
Thank you. That is completely true. Darwin's view that everything had to be gradual, the gradualist view, which was then, kept into evolutionary theory for a long time, as far as I'm concerned, is dead. I think it started to die with Gould's punctuated equilibrium. The evidence shows that it was not correct. And now we have a lot of evolutionary biologists are coming up with great, interesting mechanisms to explain how we can get this kind of, explosions and then nothing for a long time. So evolutionary theory doesn't rest on gradualism anymore. It rests on what we're finding. And what we're finding is that there are, and this is the work of James Shapiro and several other newer people in evolution, we're finding that you get very rapid, dramatic alterations, which can change body plans. And some of these are instructional genes. Most of them are in regulatory or developmental genes, which just change fast. That's probably what happened at the time of this whole gene duplication event at the beginning of vertebrates. Vertebrates came about very quickly. So the gradualism idea is kind of now becoming a straw man. I mean, there are still people who will argue that, but everybody agrees. So we can drop that part.
Well, I don't know that everybody agrees.
Not everybody.
I would say that's a strong statement.
Not everybody. You're right. There are still some people call them neo-Darwinians who don't agree with that. I think Michael Denton was arguing strongly and correctly against that view, and I share that, and many other evolutionary biologists share that.
Yeah, I would recommend to anybody interested in this subject to read Denton. It's a good book. Yeah. Steve, you ever read it?
No, I'm like I said, I'm a little familiar with it. I don't read a lot of creationist literature. No offense.
I
know Denton is not. I know Denton is not.
Yeah.
But he does.
He's not that way.
But he does advocate for teledesign, doesn't he not?
Not really. Neither does Spetner. Neither one of them come down on create. So that's I think a good point to make. When you're, it's not monolithic. Evolution is not any more monolithic than, obviously, Sy and I have vastly different views on creation. It is, I think, when it's attacked a lot of times by, people who believe what I believe, everyone kind of gets together like in Gladiator and presents this monolithic barricade. But I mean, Sy, you can agree with me or not, but there are all sorts of ideas.
Oh, yeah.
Lots of, and you're going to always get them, because this is again kind of a more of a philosophical presuppositional matter. Everything that you said, Sy, if let's say that it all fits perfectly into a macroevolutionary model, it also still fits perfectly well into the model of a young earth and special creation. I mean, obviously, maybe it's cheating to say, well, God is omniscient and omnipotent, so he can just make a Tiktaalik, which you can. But again, I'm not making that up. I'm getting that from the actual text of Genesis. So anyway, my point is, and I've said it already, these are not. You can't replace one of these models with another. You can replace one presupposition or axiom with another. You know what I mean? Yeah. There's nothing that you're telling me that I say, oh no, I can't fit that into my. You want to say comparative anatomy is evidence for common descent. I say comparative anatomy is evidence for common designer. And so on and so forth. So because this is really axioms.
Because this is a wide topic here, we're gonna try to narrow it down a little bit. But I know you're not feeling well, Dr. Huffman. So how much time do you have? Because you said before you probably don't have as long as we had planned.
Well, you want to do like 15 minutes?
Okay, because I want to make sure that because I know you're not feeling well. So let me try to focus on a few different things.
If we can do this again, so I'll do this
absolutely.
There's so much to talk about, and it doesn't have to be antagonistic either. I hope
you
no
can
one's
do it for hours, days.
No, actually, I've had more antagonistic talks with other people who identify as evolutionary creationists, because there's so many flavors, as you were just saying, of all of these ideas. That and some of that is just that's how science is. I mean, the worst controversies I've ever had was when I was a scientist and I would be in a meeting and I'd end up shouting at people who were shouting at me because of something very technical that I said. I mean, that's what happens in science.
Sure.
Well, let's actually go back to like the macroevolution thing, because there are some peer review papers out there that actually have observations of macroevolution in real time due to polyploidy and whole genome multiplication, especially in various types of plants. Wheatgrass, for example, is macroevolution. It has been actually documented that it has undergone macroevolution, It doesn't take multiple generations. Macroevolution could take 1 or 2 generations in some cases. So my question is, do you think that you guys are using the term macroevolution differently? Because the way I understand macroevolution in every literature I can find, so you would have to find me literature that's contrary to this. Macroevolution is a microevolution over multiple species. So all the evolutionary processes in microevolution, which would be adaptation by natural selection, gene flow, migration or gene drift, you have all these different things over multiple species. That's macroevolution. Everything I've ever read in biology, that holds true. It's at the species levels or higher. So if you have multiple species, you have macroevolution. So could you guys tell me your definition of macroevolution? Because you seem to have different definitions of that.
Sy, do you mind?
No, go ahead.
I can tell you the typical creationist view is not species, and there are like a dozen different definitions of species, right? They're changing all the time, and no, we're not talking about macroevolution on a species level. Is a little bit of a nonsense phrase, at least from a creationist perspective.
Right, but from a biological. From a biological perspective.
So typically when people talk about interspecies change, that's just adaptation, right? That's no problem. Usually it's, and I know you're familiar with Barrowmans and that whole idea, which I've never really gotten into too much, but that's typically at the family level. And that's what I'd say. When you see variation within a kind, and that's a biblical term, but family level, Linnaeus was a young earth creationist, shout out. That's what you're talking about. So macroevolution at a species level doesn't bother me, and I wouldn't define that as macroevolution. I don't think there's a reason to.
Okay, but my question is though, in biology, how is macroevolution defined? Not in creationism. Sy, could you maybe you can take that one? How is macroevolution defined?
Creationists can be biologists, Steve.
Yeah, I know, but how is it actually taught universally in biology?
Right. So
obviously, creationism is not taught in academics, so it's kind of excluded from that.
the way it's taught, the way the mechanism of evolution is taught, is that what you have is a continuing branching, starting from one clade level, so say a phylum or even better, a family or an order, and as you branch, you get larger and larger changes. And what happens, of course, in evolution, the way it really works, is that you have a population of animals. And that population has a lot of variation in it. And the best way that we can imagine evolution happening, and also that we've seen evolution happen when we've seen it, is that population of animals gets separated into, say, 2 groups or more. And the normal process of natural selection and also genetic drift and all the other things that go on in the genomes of animals occur in both populations, but separately, because they're separated by a barrier. They're either on different islands, or there's a mountain range, or there's a desert or something. They can no longer mate. So the changes that go on in one population are not going to be the same as the changes that go on in another population. So, for example, if you had the cat kind, the cat Barrowman coming off the ark, that whatever they were, one group of them was living here, one group was living there, one became lions, one became tigers, one became leopards. Now, you could call that microevolution, but if you take the cat kind, this is what we say in evolutionary theory, and you look at them with the dog kind and the bear kind, they all went through the same process, only at a higher level. So there was another carnivore, so to speak, at a higher level, above the family. And the carnivore went through exactly the same process and split into 3 or 4 different population groups, one of which eventually gave rise to all the cats, one gave rise to all the dogs, one gave rise to all the bears. So there's no sharp distinction made at that point between micro and macroevolution. The idea is that macroevolution is simply microevolution plus a lot of time.
Yeah, so a couple of things there. The first example you gave, we all agree on. The variation of cat kinds, that's no problem. And obviously your example was perfect illustration of how that fits into, to my model, to a biblical model.
That's why I used it.
Yeah, thank you. Yeah. Much appreciated. But the second one was not based on observation. The second one was based completely on speculation. That's not the same.
How do we know? Why is that different than the cat?
Well,
We've
I'll
never
tell you,
seen cats diverge.
sure we have. No, you certainly have dogs, but
Well, dogs is different. Okay, I'm talking about the dogs
Sure.
as a species.
So the big distinction, I think, is can they interbreed? That's a huge thing,
right?
And you do see that with the Panthera family. You do see that with ursines, and you do see that with catbirds, and you see that with all the different kinds. And I think that is a massive distinction, because if you can't breed, obviously you can't do anything with your genes. So that is a distinction that is a materially important distinction between the conception of some carnivore ancestor of bears and dogs and cats and actual cats. But again, I would encourage you to read Spetner with this idea that macroevolution is just microevolution times time. I mean, can I read some quotes and then I'm probably going to go?
Sure, but real quick before you do that, I had mentioned there is peer-reviewed papers that has macroevolution. It happens in 1 or 2 generations. Time is not a factor.
What did the wheatgrass turn into?
Various speciations of wheatgrass.
Okay, so that's
what would you expect it to turn into? I'm curious. There's something called the Meyer's law of monophyly that
I would never expect it to be anything but wheatgrass. I would never.
Wouldn't either. That's evolution.
I would never expect cats. No, it's not evolution. No, that's microevolution. That's deviation. No. Hang on. That's microevolution. What you need is something to get wheatgrass to something else.
That's not correct. Let me
explain this. Have a beer while they.
Hang on. Okay? This is very important though, and Sy, please correct me if I'm mistaken here. But in Meyer's law of monophyly, you do not lose your historical classifications, your taxonomy. So once you are in a specific group, in a monophyletic clade, you will always be in that group. So we would expect wheatgrass to always have populations of wheatgrass, one of the more specialized versions.
Sure, and
we would never expect to be wheatgrass.
Because of that, you cannot use that as evidence of a common ancestor. You can.
I'm not using it as common ancestor. I'm using it for macroevolution. Macroevolution and common ancestry are two different things.
No. That's not what we're talking about. You're kind of doing a little bit of sophistry there.
There's no sophistry there.
Let me break in. I want to ask RM a question, because what I think I heard you say just before is that the question of interbreeding is what determines whether or not micro or macroevolution occurred. So
I wouldn't say it's determinate, but I would say it's very, very important.
So in other words, you wouldn't say that every species within, say, the cat kind or the bear kind can interbreed with every other species within that kind.
No, not necessarily.
Okay, because we know that's not true.
Yeah.
So then it's we don't really have. I mean, it would be if what you said was true, if that were really true, that you could then we'd be talking about what we usually define species as, and then you'd be right, because if all cats were one species and could all interbreed with each other, you'd be correct. But it's not the case. And
well,
in fact,
all cats are different species, but they can still interbreed with each other even though they are different species. I mean, it's also not true that only a species can interbreed with itself.
That's not completely true, but it's largely true. And there are exceptions, of course. But it's not true that all the members of, I think you just said that all the members of each kind can interbreed with each other.
Yeah. No, I agree with that.
Okay.
And it's
so that leaves the question then: how do we determine those borders? How do we determine when something is macro or microevolution? If it doesn't have to do with breeding, what does it have to do with? And the best objective way I can think of to determine that is to look at the genes, look at the genetics, and that's what people do. And when they do that, they do not see a clear mark that says, oh, we've gone from macro to micro now, because these are all highly related. What we see is, the genetic differences match exactly what you'd expect if, let's say, all the animals that we're talking about came from one original carnivore population that then, diverged.
Sure.
So, and you keep seeing that all the way. That's why these phylogenetic trees are so useful, because you see that all the way back with no breaks. No breaks at all. I mean, there are breaks, but they're, for phylum type breaks.
But everything is, I mean, if you looked at the tree, if you made it a tree, there are only the tips of branches. That's generally true. You're missing so many things. And the problem is you assume that the differences are due to common descent. but you don't have a credible mechanism. Like I said, we're talking about mutation. Mutation's your mechanism, and it's not credible if you look at what mutations do. Let me give you a point. Let's say the mutation rate increased tenfold. Is that going to make animals improve, or is it going to give them all cancer and kill them? It's important to realize that mutations, and I can speak about this to a high degree as a physician, mutations, with very few exceptions, are beneficial. With virtually, I would say no exceptions, are deleterious. But most documented mutations will just kill you or make you much, much less fit. Is that a fair statement?
That's a fair statement. But it's not relevant to the question of evolution.
Sure it is, because mutation is the only way that you can get genetic change.
No, because the reason it's not relevant is that it doesn't matter how many deleterious mutations or harmful mutations there are.
Well, it will if you kill a population.
But now you have to let me finish.
Yeah,
you have to let me finish, because mutations are rare, first of all, we know. So that if individuals within a population have a deleterious mutation, they will die, which is sad, but it doesn't affect the population. On the other hand, if there is a beneficial mutation, such as the one that allows adults to drink milk, which is one of the few mutations that humans have experienced, and is still spreading through the population, that's a highly beneficial mutation. And that one single mutation made a huge difference in the lives of human beings. And that's true with all the beneficial mutations. You don't need to have more beneficial than deleterious mutations. That's the power of natural selection. One very, very rare beneficial mutation will change the phenotype eventually, when it becomes fixed, of a whole population of animals. Whereas a large number of the deleterious mutations just kill a lot of animals, and it doesn't make any difference to the population as a whole.
By the way, I think lactase persistence, I think there was 3 instances.
There are three different examples. Yeah.
I think it's important to say that when you're talking about mutations, you're concluding that they are mutations, not because you observed it, but because you've seen a difference and you've assumed that there is a descent there. So again, this is a lot of assumptions. You've seen a difference in a genome, and then you've said, this must necessarily be based on my paradigm.
That's what I want to get. I want to get back to that, because you've said that a few times, and I want to correct that. It's not that we're making an assumption. What we're making is a hypothesis. So in other words, what we're saying is, we see some changes. We see the genetic changes. We see that the genetic changes and the functional changes go together. Let's hypothesize that these genetic changes are related to the phenotypic changes we see that go on, and let's assume that this is part of evolution. Now let's test it.
Right. Let's assume it's part of evolution.
Yeah, but that's what you do whenever you're testing a hypothesis. That's the hypothesis, is to test that. Now, the whole hypothesis of the theory of evolution, which began as a hypothesis, has been tested in millions of ways. There are so many scientific fields that have contributed data to the testing of the hypothesis of evolution by natural selection, and it could have been falsified if we had found rabbit bones at the same geological level as dinosaur bones. Then evolution is dead. It's meaningless. That never happened.
Someone would come up with a new materialist paradigm. There's a lot of cleverness.
Conspiracy time.
Oh no, it's not a conspiracy. It's that people need PhDs, which means they gotta change paradigms. This is true.
If they could falsify evolution, they would get their PhD and be very famous, I'm sure.
Exactly. Yes.
Are you ready to leave us, Dr. Huffman?
By the way, let us know before you leave, because it's going to change our layout. We'll end this.
Yeah, sure. Sy, I think that was a great time. Let me just give you a couple of these, okay? Because these are not creationists talking. These are, you're talking about it's been proven. So from the 40s, so y'all know who G.G. Simpson is?
Gaylord Simpson.
Yeah. George Gaylord Simpson. Very, very famous Darwinist. And he says, I got to read now. Microevolution involves mainly changes. This is from 1949. Microevolution involves mainly changes within potentially continuous populations. And there is little doubt that its materials are those revealed by genetic experimentation. Agree. We all agree with that. Macroevolution involves the rise and divergence of discontinuous groups, and it is still debatable whether it differs in kind or only in degree from microevolution. If the two prove to be basically different, the innumerable studies of microevolution would become relatively unimportant and would have minor value in the study of evolution as a whole. Well, that's 1949, though. So he sees that, hey, maybe these two processes aren't related. So let's go up. A guy named Wesson from Cambridge says, the origin of no innovation of large evolutionary significance is known. And that was 1991. Richard Goldschmidt in 1940, again, back in time, the facts of microevolution do not suffice for an understanding of macroevolution. He was at Yale. Y'all know Lynn Margulis? Lynn Margulis would be interesting. Yeah. So, I mean, if you know,
Let me stop you. I agree with all of this. I agree with it that the mechanisms are different. And Lynn Margulis was one of the pioneers in that field. We now know mechanisms that apply to macroevolution.
I mean, in 1980, the central question of the Chicago Conference was whether the mechanisms underlying microevolution can be extrapolated to explain the phenomena of macroevolution. At the risk of doing violence to the positions of some of the people at the meeting, the answer can be given as a clear no. I don't think it's historically true to say that the macroevolutionary process has been over and over and over again demonstrated. I think the question is, I think it has not done that to such an extent that that evolutionists themselves have admitted it for decades.
Do you hear me?
Yeah, I hear you.
Okay, because
that's all. I won't keep going.
Yeah,
on.
well, I mean,
I push back on that. I don't agree with you that it's been proven over and over again. I think it's been just the opposite.
Okay. Have you heard of a book called The Arrival of the Fittest by Andreas Wagner? I don't know how to pronounce it.
No, I'll look it up.
Okay. He's an evolutionary biologist. He's one of a large group of evolutionary biologists working on something called the extended evolutionary synthesis, which agrees, as do I, that the mechanisms for variation that occur in macroevolution cannot simply be point mutations in structural genes followed by natural selection, because that doesn't innovate. That doesn't create enough newness, enough novelty to allow for evolution of macroevolution. But there are other mechanisms that have been found that do. There are, retrotransposons, this horizontal gene transfer. This is the whole epigenetics field. There are many other biological mechanisms that are now being used to follow into that problem, which you're correct. That is a biological problem that was not resolved early on. And it was one of the problems of this neo-Darwinian view of everything is a simple mechanism of gradualism, random point mutations with no teleology behind it. We don't even know that that's true. There could be evidence now that not all mutations are random, that some mutations are actually directed. All of this is very exciting, but it's still part of a new evolutionary biology. And the fact that it's, that the original Darwinist approach is being left behind makes sense. That's over 100 years ago, 150 years ago that we had origin of species. So we're moving forward with it, but it doesn't mean that evolution is false. It just means that we need to find these new mechanisms that can explain macroevolution, and I think that's happening.
So the extended synthesis doesn't disprove evolutionary biology. When you're talking about evo-devo, when you're talking about symbiosis, these are just things that are added on to the theory, correct? And also, It's funny you mentioned Lynn Margulis, because she had to fight tooth and nail to get endosymbiosis theory, through the scientists, right? And because it wasn't a very prominent thing, they were like looking at her going, "You're nuts."
She had a huge fight with Richard Dawkins.
But the evidence was the evidence.
That's famous, right?
So a lot of the people that do have controversial things or that go against the paradigm, they fight for it and they get known. So what I don't understand is, why is this such that you think that there are scientists out there that have to go with the flow, and that if they find something that is wrong, they just try to cover it up? Because I find just the opposite.
No. They where the difference is they will not question their presuppositional paradigm. And again, that goes back to what we're talking about. They will necessarily fit in. And so I know you're an exception, accepting the Francis Collins and Cy Gartes of the world. they will necessarily.
He's a good company.
Yeah, thank you.
Those are the two right there.
Yeah, the two. Two of them on the planet.
Two. No, and then everyone else is, way down the list. It's like tied for one, and then like 50 and below, whatever. But there is such a thing as an established paradigm, and the effort is not to question the paradigm. The effort is to fit new information, which science is blossoming and discovering new things at a faster rate than it ever has. But the paradigms are generally not questioned. It takes a real serious cultural shift to shift a scientific paradigm, and that's just historically true. And it happens. But usually what happens is new evidence turns into a new way to fit that evidence into the existing paradigm. And in biology, it's generally materialism. And again, my whole thing is, I'm not a materialist. My paradigm, my presuppositional axiom is that the Bible is true history. And every difference that we come down to is ultimately going to be that, and it's an axiom. So it's not really subject to argument. And I'll tell you, I think that people would get a lot further arguing if they realized in politics, in this sort of stuff, that ultimately people are really arguing about different interpretations according to their presuppositions, and not necessarily the value of the actual thing that they're arguing about. Is that fair?
I think that is fair and true to a large extent. But let me just say that my presupposition is not that different from yours, except that my biblical view is different.
Sure.
It's not made up. It's not very unusual. It's actually shared by a lot of Christians.
Oh, sure, yeah.
And so another discussion we could have.
I was going to say
that's a whole different discussion, and maybe not on this channel. But a whole other discussion is the theological implications of evolution versus creationism, and there are a lot. I mean,
there are a ton of them.
Amazing.
Yeah, hermeneutical issues.
That's right.
You guys up for that, or is that too?
I would. Yeah, no, I'm all for that kind of stuff. I love.
Oh, really? Okay.
But Tyler, that's a completely different animal.
It's too much to get on. It's a whole other subject.
Yeah.
Tyler, you were more of a.
I'm more interested if you've changed your position on marijuana yet, because I know that I had a really good convincing debate with you, and I think that I changed your mind, right? You seem a lot more chill and laid back tonight. So I think
that's NyQuil. That's NyQuil.
That's NyQuil.
That's sweet diphenhydramine.
Gateway drug.
I gotta admit, diphenhydramine knocks me on my ass, but I tell you, I have the best night's sleep. I have lucid dreams sometimes. So
it's fun, right?
But you can't take too much. And as you know, because you're a medical doctor, people should probably be aware of this. Most of the time, diphenhydramine is also mixed with acetaminophen, right? And that you can only take so much because it causes liver damage. I think it's like 4,000 milligrams, something like that. So you don't want to buy a whole bunch of NyQuil, but a little bit NyQuil. Good stuff.
Yeah, 30 cc's of NyQuil gives you 650 of acetaminophen. You can,
your liver can process that, right?
Oh yeah, 6 hours is really the recommended. Yeah. But I topped it off a little bit. I made it like 32 cc's.
You're allowed to.
I have a question from last night's debate that Dr. Huffman, I believe that you can clear up once and for all.
Triangles are actually a tool of Satan.
Well played.
They're on the satanic plane. There you go.
This is a little bit more of a yellow question, but is urine a waste product?
Urine contains waste products. So the kidney filters blood, and so the kidney, the kidneys. I hate the kidneys. Kidneys are so physiologically obnoxious. No, they're fantastically designed, but they're very complicatedly designed. Even the cursed and fallen version that we have today. But oh my gosh, they're such a pain to learn about.
But there's a lot of waste products in urine, and they're not. I mean, considerably nitrogen, calcium, sodium.
No, and it is amazingly complex and sophisticated way to filter waste products out of your blood. I mean,
if you don't filter that stuff, you die. That's why people do dialysis, right?
No. It's if your kidneys die, you have to be hooked up to a machine 3 days a week for like 3 hours to have the machine filter your blood, and even then, your life expectancy drops massively because you will slowly become poisoned because you can't filter all of that stuff out of your blood. So yes, is urine a waste product? Yes, it's a sterile waste product. So, I mean, you can drink it. It's just weird and gross. But,
well, listen, you don't know gross until you just watched last night.
Yeah, you don't talk to the people we talk to. You haven't seen nothing yet.
I don't know. I do work in the operating room.
This is true.
People drink
get together and exchange stories.
Do you have people that drink aged urine in your operating room?
I'm out. I'm
there you go.
I need to know that that's not a real thing.
It's a real thing.
It's a real thing.
Oh yes, it's aged urine. Yes,
it needs to be a theoretical proposition that you just made up because you were super high.
Nope. I wish I was. I don't partake.
A Benadryl, lucid.
Oh yeah, well, I had some.
I didn't get high enough to cope with the show that we had last night. There's not enough marijuana on the planet to get that kind of.
Okay, I'm gonna go take some NyQuil and then I'm gonna check out that show.
All right,
we're gonna have a part 2 eventually, and I do want to thank you for coming on. You're sick, and
thank you.
I know what it's like, so it takes a lot of effort to do this kind of stuff. You're not feeling
this is fun. Hey, Sy, thanks a ton. You up for continuing this if these guys allow it?
Sure, absolutely. Why not?
I think it's unless I die. Because I think I'll be okay.
We don't want to die. We don't want anybody to die. Death is bad.
All right, everybody. We'll see you tomorrow at 8 o'clock. Thank you again to Dr. Huffman and Dr. Garte for joining us. And tomorrow at 8 o'clock.
All right. Talk to you later.